Okay, so the thalamus is one of those areas that we know that is very important, but it has a ton of nuclei that can get really overwhelming pretty quickly. And so today we're going to dissect the thalamus in a very simple way. And it's going to make sense if you're a physical therapist. And so if you're new here, my name is Lily. I'm a neurologic physical therapist, and I love to simplify the complexity of neurology in a way that it makes sense for physical therapists. And so today we're going to be talking about the thalamus. So, the thalamus, we need to remember that it is what they call the relay center. Okay. So, what it means is that, so here, I love color coding. So, I'm going to color code a ton of stuff. So, the thalamus, it's like they describe it in the literature like a wedge shaped area in the middle of our brains. Okay. And actually, it is the majority of the blood supply to the thalamus is from the PCA. Okay, so that is the blood supply. Now, what's called they call it the networks, but it's basically like a loop that goes between the cortex and the thalamus. It's called the cortical thalamic network. And so what that means is that, here we're talking cortex, right? We're talking premotor cortex, we're talking somatosensory cortex. So there's information that is traveling from the cortex to the thalamus, and it kind of like goes on a loop, because this is going to make sense when we start talking about like the tracks, etc. So that's the first thing they need to know. Now, there's a ton of nuclei. We can get very overwhelmed with the thalamus really quickly, but we're not going to go there. I'm going to tell you exactly what you need to know as a physical therapist, and this is going to make so much sense while you're practicing. Okay, so the first thing is, the main thing when we hear thalamus is you can think about sensation. A big thing about the thalamus is going to be sensation, okay? So there is sensation that is moving from the periphery to the cerebral cortex, right? For processing, right? And the main two pathways that I want you to learn today are going to be called the ventral posterior lateral, okay, nuclei. So ventral posterior lateral nuclei, or we're going to call it the VPL, and the ventral posterior medial nuclei, okay, or the ventral posterior lateral thalamus or ventral posterior medial thalamus. So there's many other nuclei, but we're not going to focus on those, okay? So first thing, what are these VPL and VPM? Okay, so these are relevant areas where specific sensory information is going to arrive. Okay, so we're gonna like put a little car from the periphery. Okay, they're going to arrive to these two places, and based on where they come from, they're going to be kind of like processed there and be sent out. Okay, so that's one thing. Now let me delete this little thing. Okay, so now next thing is all thalamic nuclei. And this is going to sound like a little like neuroscience-y. All thalamic nuclei, except one, which is the reticular nucleus, we're not going to talk about that, have reciprocal, okay, you remember the loop, reciprocal excitatory connections with the cortex, okay? So thalamus loves the cortex. The thalamus loves the cortex. It is in constant communication with the cortex, okay? So now, VPL, VPM. I told you, okay, information comes to the VPL, VPM depending on where, right? So what do I mean by that? The VPL is going to have information come to this place from the body, okay, from the body. And here I'm going to give you a mnemonic so you can remember. The VPM brings information from the face, okay, or gustatory pathways, aka taste. Okay. Now, how are we going to remember this? And I laugh because I was about to choke. So how are we going to remember this too? And I'm actually going to scroll down. BPL, we're going to think about very painful limbs. Very painful limbs. BPL. Okay? VPM, we're going to think about very painful mouth. BPM. I'm going to pause the video because I'm about to choke again. Okay, now that we've recovered, I have some water. I don't know why my throat is so dry. Okay, very painful mouth. All right. So, summary, BPL, BPM. VPL is going to obtain information from the contralateral body, okay, limbs, arms, etc. VPM is gonna have information. Information is gonna arrive to the VPM from the contralateral face, okay. BPL, VPM. Got it. Now, I love this image right here. I love visuals because here it's very clear the VPM and the VPL. So we have the ventral posterior medial nucleus, VPM, bringing information from the face and from the gustatory pathways, the taste. And we have the VPL from the limbs, okay, the arms, the body. So I love this little guy licking the floor to learn about the thalamus. Okay, so now here's the main question. Okay, why do I need to care about this as a physical therapist? So I'm going to connect information for you. That way it makes sense. Okay, so we now know the thalamus is a relay center. It loves the cortex because it gets information from the periphery. It processes information. You know, it's kind of sorted out. If it's from the body, it's go to the VPL. If it's from the face or the taste, it's going to go to the VPM. Got it. Now it's going to be sent out to the cortex. What is the cortex? Meaning the somatosensory cortex. That's why I told you when you think about thalamus, a lot of it is going to be sensation. Okay, we're just talking about sensation in this video. Okay, so now we are going to talk about how do I connect information that I already know, like from spinal tracts, etc. So, for example, let's talk about VPM first. Okay, so VPM, sensation from the tongue, right? So you're eating your favorite chips, okay? So that is going to arrive to the VPM through gustatory pathways, through the cranial nerves, like cranial nerve 9. You're eating your favorite chips. Let's see, what are your favorite chips? What are my favorite chips? Oh God, I love chips. So let's put Doritos. Okay, so this is your tongue. Okay. Okay, this is a Dorito. Okay, so this is going to arrive to the VPM. Now you're happy because you had your chips. And from there, this is going to, the thalamus is, it's kind of like, oh, I have this information. I'm going to send it for processing at the somatosensory cortex. So then we have, oh God, that's a brain, okay. It's sent out, let's see, here is a premotor cortex, somatosensory cortex. It's sent out to that sensory cortex. Okay, so that's how everything connects. So when we're talking about input from the BPM, we're talking trigeminal lemniscus, we're talking taste input, we're talking, cranial nerves, etc. Now, when we talk about BPL, and this is where things will make sense with what you learned before about tracks. Oops. So now we have painful limbs, or BPL, right? So let's say you are petting your dog. Oh God. Okay. It looks like a lion or like a cat. All right. Well, this is a bulldog. A French bulldog, a Frenchie. Okay. So from here, what's going to happen is, it's coming through the limbs. Then that information, it goes up. So it's a light touch, right? Through the DCML. So now we're at the spinal cord, right? Okay, posterior cord, go up through the DCML, goes to the medulla, crosses the pyramids, etc. And then it's going to first go to the thalamus. And where it's going to arrive? Yes, to the thalamus, but where in the thalamus? The VPL of the thalamus. And then it's going to be sent to, this is the primary motor cortex. This is the somatosensory cortex. It's going to be sent out to the somatosensory cortex for processing. Okay. So let's say this cat now is angry. Like that. So now we're talking what tract, right? We're talking STT, spinothalamic. Remember, we have an anterior and a lateral. So let's say like here, STT, it goes up where? To the VPL, because it's coming from the limbs. And then from the VPL, it's sent out to the somatosensory cortex for processing. Okay, so that is just, a little bit of the thalamus. So if you're interested on watching more about, let's say, thalamic strokes or more about strokes, just click on these videos that are appearing on the screen. Otherwise, I will see you on the next video.